In this presentation, we'll learn about data visualization techniques. Now, what do you mean by data? Data is a collection of facts such as numbers, words, measurement, observation, or even just description of things. Data can be qualitative and quantitative. Qualitative data is descriptive in information, such that I had great fun. And when you present the data in form of numerical information, it is known as quantitative data. This quantitative data can be divided into two parts, that is discrete or continuous. Discrete is when you present your numerical figures in the form of whole numbers, and continuous when you take any value within the range. For example, 3.265, it is between 3 and 4. And when you talk about, say, number on the dice, which can be like 1, 2, 3, 4, and 5 and 6, so these are presented in the form of whole numbers, therefore it is discrete data. These are few questions to test you on the basis of your previous slide, whether you've got a knowledge about whether the data is qualitative or quantitative, and if quantitative, whether discrete or continuous. You can try these. One of them over here is height. Now height could be 5 feet 6 inches or it could take the form of a decimals. So it is continuous in nature, and since it can be presented numerically, it is quantitative. The most common given names in your town, these cannot be presented in the form of numbers, and therefore it is qualitative in nature. Graphs. What do you mean by graphs? It is known as the picture is worth 1,000 of words. That is, you present this entire collected data in the form of pictures. This pictorial representation is known as graphs. These are basically important for the analysis point of view. When you are given a data, you cannot give any conclusion based on this numerical figures. So you present them in the form of a picture, which makes it easy for you to understand. Therefore, graphs are the picture representatives for one or more set of information and how these visually relate to one another. For almost any numerical data set, there is a graph type that is appropriate for representing it. Graphs help you present the data in a meaningful way. It is one thing to see a data listed on a page, and it's another to actually understand the details and trend of the data. Using graph, we can depict the data, and well-made graphs convey information quickly. Now there are 6 types of graphs we'll be talking about in this presentation, that is bar graph, histogram, line graphs, pie charts, scatter plots, and time series graphs. Bar graphs. Bar graphs are also known as bar charts. It is a graphical display of data using bars of different heights. Also known as Pareto diagrams, a bar graph can be horizontal or vertical. Each axis is labeled with either a categorical or a numerical variable. The bar heights are scaled according to their values, and the bars are compared to each other. For example, you conducted a survey to find out which movie is liked the best. There are like comedy, action, horror, drama, romance. So when you plot these numerical figures in the form of diagrams where your x-axis depicts your comedy, action, romance, drama, and your y-axis depicts your numbers, so plotting them, you can easily show that romantic films are viewed the most. Now, bar diagrams are good when your data is in categories such as comedy, drama, etc. But when you have continuous data, you present them in the form of histogram. It is best to leave gaps in between the bar of the bar graph so it doesn't look like a histogram. Therefore, a histogram is a kind of a graph that uses bars, right? But on the x-axis, you plot the continuous figures. For example, in this graph, 100 to 150, 150 to 200, 200 to 250, and so on. When you do not put gaps in these bars, it is basically a histogram that we are talking about. Another form of a graph includes line graph. The graph shows information that is connected in some way that is, for example, change over time. For example, look at, you want to collect the facts upon astrology and you want to check whether, test these how good you are in this. So in day 1, day 2, day 3, day 4, when you plot them with the line, you can compare your growth. Comparing these set of data can be complicated, but line graphs make it easy. The plotted peaks and dips on the grid allow you to monitor and compare the improvement and decline. Therefore, the line graph shows whether if it's moving upwards, you show that if there is an improvement. If there is a downfall, you show that you are lacking in some information. The pie charts. Now, when you present your data in the circular form, it is known as a pie chart. That is, formally, a special chart that uses pie slices to show relative size of data is known as pie charts. For example, take the previous one, the comedy, action, romance, drama, and horror. There you present this data, these figures, in the form of pie. Now you can easily conclude by looking at this diagram that romantic films carry 30% of the weightage, that it is viewed the most. Now the question comes, how do you actually draw these pie charts given the data? So first, put your data into the table like the above one, and then add up the values and total them. For example, 4 plus 5 plus 6 plus 1 plus 4 equals 20. Divide each value by the total and multiply by 100 to get the percentage term. Now you need to figure out the degrees of each pie slice. The full circle has 360 degrees. So it is like for the comedy 4 by 20 into 360. For horror 4 by 20 into 360. For romance 6 by 20 into 360. So this figure in the last line, 72 degrees, 90 degrees, 108 degrees, 18 degrees, 72 degrees, is basically the degrees of the pies. Now you can use the protractor to draw this pie chart. The next one is time series graph. The data is displayed in the time series graphs at various time points. The vertical axis is for the data values and the horizontal axis shows the time. This type of graph can be used for showing the various trends through the various time periods. For example, the number of road deaths from 1921 to 2013. It shows there was an increase in number, then there was a downfall from 1939 to 1945, then further increase. So this is basically showing the various number of road deaths, that is the deaths on the road at various time periods from 1921 to 2013. The last one is scatter plots. The scatter plots XY plot has points that shows the relationship between two sets of data displayed paired in values. It is in the form of a Cartesian XY coordinates with the vertical y-axis and horizontal x-axis. For example, here we take the example of temperature and the ice cream sales. The local ice cream shop keeps track of how much ice cream they sell at various known temperatures of the day. So here we can, when you plot these figures in the form of a scattered diagram with the x-axis depicting temperature and the y-axis depicting your ice cream sales, you find these plots which clearly shows that warmer the weather leads to more sales. Scatter plots you will study further helps you to find the regression analysis, the correlation, that could be positive correlation, negative correlation, and so on. It basically helps you explain how the x and y variables move in a particular fashion. You'll get to know this in the previous slide. I hope this presentation has helped you get a clear understanding on the graphs, that is the pictorial representations. Thank you.
Hi, in this video I'm going to show you how to create bar plot of a given qualitative variable in R. We're going to take a data set. So here is how the data set looks like. We have got information about car sales. So for that we have information about the make, model, type, of the car. We also have information about the origin of the car. So there's so many columns, so many variables. We're going to take only one of the qualitative variable. Okay, there are several of them. You can use several of them, but just one of them will take the origin. So it has values like Asia, Europe, and US. So it's the origin of the car, so where the car was made. And then we're going to create a bar chart of this qualitative variable. So before that, let's see how the frequency table looks like. We're going to use the function table, and just to refer to this column, we're going to use data, and then the dollar sign and the origin, just to refer to this variable in this data set. Okay, and let's see how the frequency table looks like. Okay, so this is how it looks like. Okay, let me take it. So this is how it looks like. Okay, so we have one meshing values also, but other than that we have Asia, Europe, and US. So we can create a visual plot of this by creating bar chart. We'll use the function bar plot, and the variable where we have saved our the table, the cross table, or the frequency, we can use that as a parameter, and that's what we have done. So bar chart is the bar plot is the function, and frequency is the parameter. This is our bar plot. Okay, so this is a visual form of showing your data, or just presenting your data. So it's so easy, right? Much better than Excel, I would say. And then you can set different colors, like to different category. How we do that? We set colors like this. Okay, and then in the bar plot function, we pass another parameter, okay, which is the color parameter. And when we'll run this, we'll get a different colors for different category. Yeah, so it's much better, right? Much better to present, and you can choose your color, which color you want. So it's up to you to decide what color you want in this plot. Thanks. We will see in this video how to create box plots in R. Box plots are very useful to understand the distribution of data. It's a visual way of understanding the distribution of the data. So for that, we will first define a variable, a numeric variable. So we'll define a variable x, and these are the values. You can also import data to R session and then use box plot. That's also possible, but since I haven't done that, so I'll simply create a variable having certain number of values, and then I'll use box plot function to create box plots. The parameter that will be used is the variable that we just created now, which is x. Okay, it's as simple as that. When we run this, we will get the box plot. So this is how it looks like, but it looks vertical, right? But we can also get horizontal box plot. If you do not specify anything, it will always give you the vertical ones, but we can also get the horizontal box plots. It's the same. It's just a way of your it's just a matter of your test, which one you want, horizontal or the vertical one. Horizontal one, you have to have another change to the syntax, which is horizontal equal to true. So that's the only statement that you need to add apart from the variable which is x. Hi, in this video I'm going to show you how to create histogram for a continuous variable in R. I'm going to take a data set. So here is how the data set looks like. So we've got data for car sales, and in this data we have details about the cars that were sold. So we have different variables of the car, and the variable that we're going to use for the histogram is the horsepower of the car. Okay, this is a continuous variable. We are going to use this variable to create a histogram. Histogram can be created by using the function hist. Okay, a simple histogram can be created by using this function. How we use this, how we refer to this variable in the dataset is like this. Okay, data is the name of the dataset, and then followed by a dollar sign and then the column name. Okay, You can assign it to a different variable if you want. Otherwise, simply you can copy paste from here and put it in the as there's a parameter to the function hist. Otherwise, just assign it to a different variable and then pass that as a parameter to the function hist. Alright, so this is how it looks. So this is our histogram. As you know, histogram is used in the continuous variable. It's more of a continuous variable form of the bar chart for categorical one. Okay, but we can make it better. Like we can assign colors to different segments and so on, right? So how we do that? We assign colors like this, and then we use more parameters. Like colors can be used as one of the parameters. So here we have used. We can also give a title to this. So we use the main, and then you can put a title here within the double quote. And then we have x slab. That means in the x-axis, what is that you are plotting. So here we are plotting x horsepower. So we that's what we have given here, right? It's up to you to use. We can have more parameters as well, but I've taken only this. If you want to know more, you can always go to the official documentation of the hist function. Okay, let's run this and let's see how it looks like. Okay, seems to be some issue. Okay, let's run this. Alright, so here you can see in different colors. It looks much better than the earlier one. So you can always use colors according to your ways to have a better visualization of the data. So that's how we can create a histogram in R. Thanks. Hi, we'll see in this video how to create scatter plot in R. For that, we'll use a data set. We'll use the car sales data set. Let's see first how it looks like. So this is the data set for car sales. It's got different information about cars, make, model, size, horsepower, weight. So we like to plot how horsepower is related to weight of the car. Alright, so the two variables of interest to us are horsepower and weight. And this is how we reference a given variable in R. So we first take these two variables and then we will plot the scatter plot. So the syntax is very simple here. We'll use the function plot, and then here we see the the x in the x-axis, the variable in the x-axis, and then followed by the variable in the y-axis. Okay, you can change it also depending on how we want. Alright, we want horsepower to be in the y-axis, weight in the x-axis, and then in the graph, right, we also want to label it, right? Label the graph with y lab is horsepower of the car, x lab with weight. So you can give any name you want depending on the convenience, depending on your requirement. Okay, so let us run this. So this is how it looks like. So horsepower, as you can see, we have labeled it, right? Horsepower of the car, and here in x-axis you will see the weight. And what you see here is that horsepower is increasing with weight. Right? There seems to be a linear relationship between horsepower of the car and weight, and horsepower of the car is increasing with weight. What we can do also is that we can fit a regression line to this, and that will give a better picture. Right? Oftentimes that is very helpful just to see the trend. And to do so, we'll use the function abline and also the function lm. So lm is used in the linear regression. Those who are familiar with linear regression would know that in R we use lm function for that. And then we start with the y-axis variable. Here it is horsepower, and then weight, which is in the x-axis. Okay, so let's run it now. Now you see the regression line that goes in between these points, right? Those who are familiar with regression, is basically a line that fits the data point in such a way that the difference between the distance of the data point and the regression line is the minimum, right? The sum of the square of the distance, and it includes all the data points. Okay, so it closest resemblance the data point, the pattern in the data points. Okay, so that's how we should interpret. One thing to remember here is that to see to keep the order of the variables. For example, if you interchange you're not going to get anything. Okay, let me do this. So if you simply interchange weight with respect to height, you're not going to get anything. So the regression line is not going to be appearing on the graph. Why? Because here we see, we have defined x and y, right? So we cannot regress x with y. We have to always regress y with x. Those who are familiar with regression would know this, that y is the dependent variable and x is the independent variable, and the assumption here is that x variable is a fixed variable. It's not a random variable. Therefore, you will not get a regression line in that case. But otherwise, if you keep your y and x correct, then you will always get a regression line. So that's how you create a scatter plot and you fit a regression line to two variables. Thanks.